The next presentation in this session is AI-enabled cloud data centers driving intelligent operations in the iron and steel industry. This is from Seth Sale. The speaker is Ms. S. Selvi, GM and HOD CNIT. Ms. Selvi is a seasoned IT professional with over 25 years of progressive experience in software development, business process automation, database architecture, networking, cybersecurity, and cloud implementation. She has demonstrated expertise in designing, integrating, and managing enterprise-wide digital solutions that drive operational efficiency and data-driven decision-making. She has also proven leadership in establishing robust NOC/SOC frameworks, implementing hybrid cloud architectures, and modernizing legacy systems through Industry 4.0 and data analytics initiatives. Ms. Selvi.
Thank you, ma'am. Good afternoon, everyone. So today we will explore how AI-enabled cloud data centers are revolutionizing operations in the iron and steel industry. These technologies redefine efficiency, intelligence, performance across steel plant function. Let us see how the synergy between AI and cloud is shaping the future of steel production. We all know this artificial intelligence and machine learning are becoming the backbone of modern steel making. So basically, these AI/ML technologies form the backbone for modern cloud data centers. These are the functionalities of AI/ML for maintaining the modern cloud data centers: predictive maintenance, energy optimization, cooling efficiency. AI dynamically controls the cooling system. About 30 to 40% of energy saving is reported. And intelligent workload management, where and when to run the workload. The balance between the servers are automatically, dynamically managed using AI/ML algorithms. Cybersecurity and threat management, the DDoS attack or any intrusion across the network is being managed by the cybersecurity. There are later solutions like SIEM-SOAR, which automatically takes care of the cyber threat across the organization. Capacity planning, resource forecasting, the compute, storage, and the bandwidth requirement are taken care by AI/ML algorithms. Network optimization, the latency drop, the congestion, all these are, whatever the problem across the network, are being taken by the AI/ML algorithms. Then automated operations. Now the entire database management is manless because of AI/ML algorithms. Then data storage optimization. The data which is frequently accessed is kept. There are different tiers in the data center, the hot, warm, cold. Accordingly, the data is automatically shifted in the respective tiers. Sustainability analytics. This is very important. The power usage effectiveness and the carbon metrics are managed by AI/ML. Then we have different AI infrastructure. There are different, plans like platform as a service, infrastructure as a service, software as a service, data as a service. So all these functionalities are built for modern cloud data center. These technologies, these algorithms is not only for driving the business, but they are the backbone for driving the iron and steel industry. So the forging the future of steel production, the predictive maintenance, we all know the AI/ML predicts the failure before in time, so it helps. Basically, the algorithm read the temperature, vibration, acoustic data to detect the early signs for breakdown. The maintenance is done only when it is required. Because of that, the maintenance cost is reduced, downtime is taken care, and there is a continuous steel production. This AI-powered quality control is another interesting area. The machine learning algorithm continuously scans the steel surfaces to identify the cracks, scratches, and for any inclusion. And in the rolling mill, by monitoring, by using the vision-based computer system, a 1 millimeter flaw can be detected on a fast-moving coil. This is fantastic, and the accuracy level reported is 99.5, and it leads to production. AI does not just monitor, but it optimizes. From plasmaless charge mix to continuous casting speed, these algorithm enhances every process step. They balance yield, reducing carbon dioxide emission, and efficiency, energy efficiency is enhanced significantly. In short, AI transfers every ton of steel into a smarter, greener product. Let us see how cloud computing forges the future of the steel industry. The big data challenge, starting from the IoT sensor data, the process data, the quality data, it's a terabyte of data is required to be maintained. This is not possible on-prem. That becomes, the cloud data center becomes the foundation for Industry 4.0. Cloud, the bedrock for Industry 4.0. The cloud computing unifies smart factory ecosystem. It stores the data, processes all of the IoT data in one central platform. For example, the digital twin production can be simulated in real time on cloud. This is the brain. Cloud is the brain that powers AI/ML. When AI meets cloud, the steel production becomes agile and intelligent. This provides smarter, more sustainable steel ecosystem. We have implemented recently, we have shifted our on-prem data center to cloud. The traditional data system, the data center DR system, it's very difficult to maintain online because of lack of expertise. We need expertise on VMware. Then every 5 years, the obsolescence is reported. So, and the capacity also only hardly 50% of our data center was being used. So, since we are in the era of Industry 4.0, we smartly moved over cloud, and I can guarantee it is 100% uptime. So this is a glance of our data center, cloud data center. It is on Microsoft Azure in Pune. We have 2 internet lease line, 100 Mbps lease line. We are efficiently managing the entire business show without any interruption. So the intelligent cloud, how AI is forcing the generation of cloud computing. So it is the AI/ML helps the cloud data center to self-evaluate, take care. It automatically, in case of any problem in the server, the AI algorithm helps to restart the servers automatically. And it's not only from the cloud. Now we have gone to edge computing. The models which is trained on cloud, now it is run on the edge devices, IoT devices that provides instant, fast, and the low-cost effective solution and better latency. So AI in cloud native platform systems, from intelligent serverless to AI-powered smart security, this AI is driving the cloud efficiently. The killer app. Today we are in the era of generative AI. The cloud is consumed worldwide heavily for generating the text, images, document processing. So it's the AI/ML technologies are not only central to how modern cloud data centers operate efficiently, securely, and cost effectively. Concluding, they provide computational intelligence, scalability, and resilience required for implementing Industry 4.0, and they are the digital backbone of iron and steel industry transformation. By leveraging cloud-hosted AI solutions, steel enterprise can achieve higher productivity, energy efficiency, and sustainability, leading to a more competitive and smarter industrial future. Thank you so much.
Thank you, Ms. Selvi. The next presentation in this, the last presentation in this session is transforming blast furnace stockhouse operations through AI-based predictive material modeling. From InSmart Systems, we have speaker Mr. Abhinav Bisen, Joint MD. Mr. Bisen has done his BTech in Electronics and Instrumentation Engineering from Vellore Institute of Technology in 2008. He's an MSc in Electrical Engineering from University of Southern California, USA. He also holds a Master of Business Administration from University of Cambridge, UK in the year 2020. Currently, he is holding the post of Joint Managing Director in InSmart Systems India Private Limited from 2022.
Thank you. Thank you very much, ma'am, for the kind introduction. And I also want to thank everyone on the dais here for establishing a very firm foundation for AI. Most of the speakers here have actually covered most general use cases, so I will, it's quite lucky that I'll be focusing on a very clear and a very pointed application for AI, which a lot of my customers, that is Jindal, ArcelorMittal, Tata, Vedanta, a lot of these people seem to have this pain point in common. And what I wanted to do was to combine the traditional strengths of my company, that is machine manufacturing, automation, with AI, and serve a purpose within the next 6 months. So this is our attempt for that. Typically what happens in your blast furnace is you have multiple ingredients which are sort of fed into the blast furnace using the stockhouse. The stockhouse is composed of multiple silos. The problem is that we don't know what is going into the blast furnace on a real-time basis. Basically, from a chemical standpoint, the chemistry of the material that is going to the blast furnace, and also from the granulometric standpoint. If we can know what is being fed into our blast furnace before it is fed, then we can employ the multiple algorithms that the senior people have discussed here far more effectively. Why this has not been implemented right now? Well, think about it practically. You have around 20 to 30 silos inside any stockhouse. Getting a sample from there, analyzing it, that's a 2-3 hour thing. And after that also you don't have what is the actual content of the silo as a whole. And you also cannot predict what is going into the skip hoist. So that is the problem that I want to solve using AI. So as you can see, that is a typical sort of the diagram there. That's a person who's actually sort of taking the sample, and those are the bunkers from which you actually take the thing, and then take the sample, and then there's a skip hoist which goes and sort of feeds the blast furnace. Even if you were to take the sample out of the skip hoist to understand what is the iron quality, the percentage of iron, the quality of coke, the quality of dolomite limestone, it will be too late, because by the time you analyze it, that thing has already entered the blast furnace. So how do you control something you can't? So the approach that I took for that was, if you can't measure it, at least predict it. And that's where artificial intelligence can help us. So this is a typical thing, right? You have multiple raw material bunkers, you have multiple grades of pellets, iron ore, dolomite, limestone. We can't really put sampling systems over there. So what we've decided is, right at the input of the belt of the stockhouse, we will be putting a sampler and an automated robotic lab. I will take you through that, which will give us the chemical and granulometry of whatever is going into the bunkers. And once we know that, we need to 3D model the entire bunker. Once you can do that, then you know what is being fed. So basically what we need to implement is a physics engine, because these are physical processes. You're taking something from a conveyor which drops into the silo, and then it builds a heap within the silo. So you need to have a physics engine which takes into account the size, shape, density of the various particles. You need robotics, and you need very good analyzers to analyze what has gone. Then you need to build a 3D digital twin, and then you can predict the base mix. That is the crux of the problem we'll be solving. I'll be showing you the digital twin of a silo that we have built. Just look at the videos. So this is an iron ore pellet simulation. As you see, the color of the pellets is changing. We want to simulate that as in how the iron ore pellets enter the silo, the quality can change. So each of these balls represents around 1 ton of iron ore, which we have analyzed as it enters into the stockhouse using the cross-built sampling at the beginning of the circuit. And we have the robotic lab over there. So now if you see, if we say the darker pellets are of higher quality, those are the ones that will be fed into the blast furnace at a successive stage. So we know where these pellets are, the quality of the pellets and where they lie within the silo. The same thing can be done for dolomite, coke, iron ore for their corrective things. And this is not some futuristic technology, we've already achieved this. This is there in India, it is made in India, and I hope the dignitaries here give Indian companies a chance to prove themselves. So yeah, this is the simulation that I came up with was this. As you can see, we have shaded the quality as per the variation in the quality. So let's say in the subsequent step, even lesser quality comes in. You will know the lesser quality sample is the material is sitting at the top, and the higher quality is sitting at the bottom. So what you're about to discharge in the skip hoist will be the better quality one. I used to play a lot of video games, and all this sort of programming came from that background. What you're seeing here is the bedrock of what creates artificial intelligent video games, and that's from my experience with Pixar. I used to work for them before. I'll just quickly show you the sampling. I'll have to skip over it. My colleague will just show the sampling part. You can just go faster. So I could not get a stock image of the stockhouse, but basically this is what the bed to a stockhouse would look like, and that over there in the blue is the sampling system, which will take the sample and feed it into a robotic lab. Now, what does a robotic lab, a remote robotic lab look like? Just one second, I'll just finish this part as well. So that's a robotic lab. So that's a robotic lab, which is the crucial part, and I hope we get the opportunity